Yeah, he said there's 10. I made a quiz list. Anyone wants to use that?
Whoa. Oh, me too. I wanted to. I want to learn. All right. So the rest of this unit, we're going to work on when a metal and a nonmetal combine, when a cation and an anion make a compound, how many of each do I need? All right. And then how do we name them? What do we call them? All right. So this is going to be like, you have probably all heard table salt is sodium chloride. And you know that it's NaCl. Right? The stuff they put on the roads in the wintertime is calcium chloride, but it's CaCl2. So we're going to figure out how to name them, how to write the words if I give you the symbols. And then if I give you the words, you need to figure out how many of each are there. So today we're going to do the basic ones, and you've got to come back tomorrow, like understanding it, having the charges down, understanding what's happening, so we can do the harder things. And you'll just practice. You'll get a lot of practice in. We'll do a few examples of each, and then you're going to sit and practice tomorrow. Friday we'll do a lab with it where you identify what's inside of unknown, just to make it, I don't know, slightly more entertaining than just, here's some more practice. So we're going to do binary ionic compounds first. So we got to talk about what a binary ionic compound is. What does the prefix bi mean?
2.
2. So this is an ionic compound. Composed of 2 elements. All right, so just 2 elements. Right? It is ionic. So for the elements inside of an ionic compound, you have to have one's a metal, and the other one will be a nonmetal. And those are going to be your 2 elements. You're going to have a metal element and a non-metal element, and the 2 of them are going to join together. They're going to transfer their electrons. Remember that when we transfer our electron, our metals give them away, and they become our cation. Remember that has a positive charge. And our nonmetal takes the electron or electrons and becomes our anion, which has a negative charge. And then that's what sticks together. Okay? And so when we talked about this yesterday, we drew the little pictures to like show them physically transferring. Sometimes it's really nice. The metal has 1 to give away. The nonmetal only needs 1. They transfer the 1. Life is grand. Right? Sometimes you make a combination. You can combine any metal with any nonmetal you want. All right. In the world, I'm sure it exists as a compound somewhere. So you can take a metal that only has 1 to give away and combine it with a nonmetal that needs 2. And so in the little pictures we talked, well, sometimes you need more than 1 of your element. And that's kind of what we're going to work on. All right, this stuff we do today and tomorrow, we do from now until May 30th. All right, like until the end of chemistry class. So like, please, 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 if something doesn't make sense, you need to ask, because we are going to do this for all eternity. It's going to feel like that. All right. All right, so first thing we're going to do is we're going to learn how to write their names. All right. So for naming, this is going to be, I give you the symbols. So I tell you like NaCl. I tell you CaCl2. I tell you Al2O3. And you're going to turn it into words. So think back when we learned our element symbols. This would be like on your your second test, when your learning target was like, know the symbols for elements. So like on your test, I could put C and you'd have to write carbon, or I could put fluorine and you put F. Right? But this is going to be, I put C, you write carbon. I put Al, you write aluminum. But now we're going to do it for compounds. Okay? And it's pretty straightforward for ionic compounds. Step 1, you name the metal. Your metal, am I in the way, Sophie? Just like to make sure my voice is on the screen. So name the metal. It'll always be the first element, so we always have the metal come first in our ionic compounds. The cation, the positive one, is always first. So you're just going to write the name. So if it's Li, you write lithium. And if it's Al, you write aluminum. And if it's Ca, you write calcium. Right? For the metal part of it, it's really just the same as it was with matching element symbols. Right? Like just write the name. Right? Just got to remember where they are. The second thing is you're going to name the nonmetal And they are two words, like they're two separate words. We don't combine it into one. So you name the metal, put a space, and then we name the non-metal. But we change the end to be IDE. And this is why table salt is sodium chloride, not sodium chlorine. This is why in your toothpaste it's fluoride, not fluorine. It's tin fluoride that is in your toothpaste. It'll say stannous fluoride, but it's tin. This is like if you read your salt, like if you buy those like big canister of salt, you know, like in your cabinet, it'll have potassium iodide in it. Right? They add it to give you iodine in your diet. So that we change the ending to IDE. Now, for the halogens, that's pretty easy. All right, they all end with INE, so you just change the N to a D. So fluoride, chloride, bromide, iodide. The other elements are a little more interesting. So oxygen is not oxygenide, it's oxide. And these will start to sound like, I promise, like a little more comfortable as we do this for the next few weeks. Nitrogen goes to nitride, and again it's a D, I-D-E, nitride. Sulfur goes to sulfide. It's not sulfuride, it's sulfide. What other weird ones?
Hey, how do you like know like it's considered the ending?
Because it comes second in the name.
No, like the ending in like the word. Like,
Oh, I'm teaching you what they're going to be.
oh, like those are the only possible.
Well, it's all the non-metals, so like there's a limit, I mean, to what it can be. And like you will get more comfortable because you'll read them too, and so you'll get more comfortable with what they're gonna sound like. So like right now I get it, they're gonna be funky. But phosphorus goes to phosphide. So it's not phosphoride, it's phosphide. Selenium is selenide. If carbon came up in it, it doesn't often, it would be carbide. This should get you through. And then, like I said, the halogens are nice because the N just changes to a D, like for all three or all four of them. But these are the weird ones. And like I said, you'll get more comfortable with them. But they do always change to IDE. So like when you read chemical formulas, and that'll be our project this quarter, is going to be, once we learn how to name covalent and ionic, you're going to start reading labels in your home, everyday items, and you'll start to recognize the words and what they mean. All right. So you're going to turn to your friends, you're going to say, good morning, and you're going to try it. You should have 4 there. Ignore the numbers. I didn't say anything about numbers yet.
Sodium, potassium.
Sodium.
P is not potassium.
Oh, yes.
Do you do comma or just a space?
Just a space. So name the metal, put a space. Name the non-metal, change it to IDE. It's a 2-word answer.
I was like, wait, don't the numbers mean that there's like 3 of that element?
It does, but in ionic compounds, we don't care about them, we name them. When we go the other direction, I'll talk about how do we know. Like a chemist, when you say sodium phosphide, they know that it's Na3P. And you will too. We're going to talk about where it comes from.
Wait, chloride.
Bromide. What are these?
How do you spell magnesium?
We're going to use them in a second. Magnesium.
Wait, CA is.
Okay.
Ca is not carbon. C would be carbon.
Calcium.
Should I find my element symbol Quizlet and add it again to the
Wait,
to the roadmap?
bromide?
No.
Bromide?
Honestly,
Yeah, like
I
preferred.
studied them
That's like
like
preferred.
I mean, yeah, you're going to get better with the symbols and the names because now we're going to use them every day. And you're going to go both directions right now. All right, my little transition metals. What's the first one?
sodium phosphide.
Sodium and then phosphide. And again, it is 2 words. Also, a side note, I'm not being picky about it, I don't really care, but they're not proper nouns, so you don't capitalize them. Like, they're not, like, a name of a city or
Tell me that's
person.
25 off.
On your paper, it'll be 0.5 off. All right, my halogens, what's the second one?
Are we the hell? Oh, yeah.
You are the halogens.
Magnesium nitride.
Magnesium nitride. I am kind of nice on spelling, so long as you don't look like you're trying to combine two elements together to make, one, because you don't know if it's magnesium or manganese, and you're like, magnesium. I'm pretty nice. Alkali metals, what's the third one?
Aluminum chloride.
Aluminum chloride. And then my noble gases.
Calcium
Bromide. And like I said, it will get better. Like, we'll do this a lot, so you're going to hear them. Just right now, you don't hear a lot of the words, so you wouldn't be used to them. But start reading labels, because you will start to see it on stuff. Like, they will start to be familiar to you. Now, so notice we don't care about the numbers. In ionic naming, we don't specify how many of each element is there. All right? We literally just name the first one, name the second one, change it to IDE. But a chemist, when they hear sodium phosphide, they will know that there are 3 sodiums for every 1 phosphorus. So here's the question. How do they know that? All right, well, you are chemists in training, so you are also going to be able to figure this out as well. So at your little table, you should have some little ions, little pieces. Some positives, some negatives, some 1s, some 2s, some 3s. Find your little pile. All right, now, we talked yesterday that certain groups always do certain things when they make an ionic compound. All right? So in our first compound, we've got sodium and we've got phosphorus. All right, well, sodium, look on the periodic table. It's an alkali metal. The alkali metals always give away 1 electron, right? They always have 1 more electron than a noble gas. And if they want to be like a noble gas, they have to get rid of that 1 electron. So they're going to be +1, right? So find your little 1 plus. So there's one of your little sodium ions, okay? And it's combining with phosphorus. All right, well, phosphorus is a pycnogen, right? Well, we look at group 15 on the periodic table, and group 15 is like, gosh, if I could just have 3 electrons, I could be a noble gas, right? Everyone's goal. Please tell me we got that question right in our quiz. We all want to be noble gases. So group 15 is always 3 minus. So find your little 3 minus piece. Okay. So how do we know that we're going to need 3 sodiums? Oh, you fixing my sign? Thank you. I didn't do it yesterday. All right. So we have our 1 little sodium, and here's your phosphorus. Why are we going to need 3 sodiums to make it happen?
Because it takes 3 more charges to get to 8.
We got to get our charges to be the same. So when ionic compounds get together, your positives and your negatives always have to be equal. So we put our 3 little +1s on there, and you get your nice little pretty rectangle. Okay. So that's why there's 3 sodiums and 1 phosphorus. Okay. Yeah, it might have dropped because the last bell wasn't very nice to theirs. All right, on the next one, okay, we're going to build a new one. We've got magnesium with nitrogen. All right, so magnesium is an alkaline earth metal. It's in group 2. The group 2s like to get rid of 2 electrons, so they're always +2. They always give away 2. Okay. Nitrogen is also a pycnogen like phosphorus, so it's going to always want 3. Okay, so find your little 2 plus, find your little 3 minus, and I can't hold this one up as easily as you all can do on the desks. All right, so you're going to fill in, all right, you look at them, and this one still needs a spot, right? So we got to find another +2 ion. All right, so you fill that one in, and what's happening on the other side?
It's too big.
It's too big, so you need another 3 minus ion, and this is where I can't keep going, like I'm not,
I can.
okay, we got this. All right, we'll fill in our little 3 minus, and then you can see you got 1 more spot.
Every 6.
All right, so again, your positives and your negatives have to be equal. So in this case, we've got a -6 and a +6. Okay. On our third example, all right, we find aluminum. Aluminum doesn't have a cool family name. It's just in group 13. But group 13 always give away 3. So it's going to be +3, always. Yeah. So here's little group 3 plus. And then chlorine's in 17. Well, the halogens are so close to being noble gases, they only need 1 more. So they're 1 minus. So we put 1 little chlorine in, but how many more do we need to make it into the rectangle.
2.
So we need 3 total, right? So they always combine so that the positives and the negatives are the same. Right? In our last example, calcium's a positive 2. No, the goal is to eventually not need them. But like right now, if they help you visualize it, then that's why they're going to sit on your desk for a little while. Calcium is plus 2 minus 1. Now, all right, so chemists know these, okay? You are now officially chemists. You also need to know these. So you need to get into your head that group 1 is always positive 1. Group 2 is always positive 2. Group 13 is always positive 3. We skip 14. Group 15 is negative 3. Group 16 is negative 2. And group 17 is negative 1. Honestly, if you can remember 1, 2, 3, skip 3, 2, 1, it's always positive than negative, like that.
Wait, I'm confused. What do you mean for 15?
So group 1 is 1.
Yeah, I get that.
Group 2 is 2, 13 is 3, you skip 14,
But wouldn't 15 be like plus 3?
though they're minus 3 because they take 3 electrons and electrons are negative.
We are. Oh, because they're.
Non-metals are always negative.
Oh, okay.
18 minus
Wait.
5.
But like, you just look at like the number of valence electrons.
We'll tell you how many more they need, yeah. Alright, so, now, no one's going to want to use puzzle pieces for the rest of the year, okay?
Yeah, I do.
Well, you're not going to,
Keep it on
you'll
test.
never finish anything. No, by the time we take our test, you're going to be able to do this without puzzle pieces, I promise you. Alright, so I want you to look at kind of a pattern with it, alright? The second example is probably the best one to look at to start. Notice that magnesium always has a positive 2 charge. How many of the nitrogens did we have? 2. So that 2 right here tells me how many N's I need. All right. My N always has a negative 3 charge, and guess how many magnesiums I need? 3.
3.
All right. So the charge of your atom, ion, tells you how many of the other one we need. All right. So up here, sodium had a positive 1, so we only need 1 phosphorus. Phosphorus had a negative 3, so we need 3 sodiums. All right, so the charge of the 1, and you can ignore the positives and the negatives, honestly, will tell you how many of the other one you need. And we call this crossing your charges. And you're going to hear me say this, I don't even want to know how many times between now and May 30th, all right, to cross your charges. Right, because that's what we're doing. The charge number for one of the ions tells you how many of the other you need. Right? Now, what if they're the same? You're going to like when they're the same, right? If it's plus 1, minus 1, you just need 1 of each. If it's plus 2, minus 2, guess what you need? 1 of each. If it's plus 3, minus 3, you just need 1 of each. All right, those are the nice ones. Okay? Things to remind you, because you should know this from junior high / even in biology class, that if you only have 1 of an element, we don't write ever. You never write a subscript of 1. The symbol there tells you there's 1 of it. If it's got a little number next to it, that tells you how many there are. Okay? So we're going to walk through the steps of how to do this. The goal is within the next few weeks to be able to do it without writing anything down. Some of you will be able to do that today. All right? Some of you will still want puzzle pieces. Some of you will want to think about drawing them. Some of you will want to write it like I'm showing you. Goal is to eventually be able to read sodium phosphide, look at the periodic table, and be able to say how many of each there are. Okay? You always get a periodic table from here on out, so just keep that in mind. All right, so this time we're going to take names. So we're going to go from words, and we're going to turn them into symbols, where we can say how many of each element do we need. So step 1 is going to be to write the symbol and the charge, so plus 1, plus 2, plus 3, for the cation. The cation is your metal. It's always first. Okay. Step 2, we're going to write the symbol and the charge for the anion. The anion is your nonmetal. it's always going to come second. So we always go positive then negative, always. And then we're going to do a little cross your charge thing. So the number from one charge tells you the subscript for the other. And I'll show you how to, like, what I do. And then, like I said, you eventually will get to, I hope, where you can just look at the periodic table and figure it out. But for now, it's fine to write things down. Okay? Last step is going to be to simplify if possible. That happens if you end up with a 2 plus and a 2 minus, or a 3 plus and a 3 minus. Like those you just shove together. That's literally what I do when I write them. So if I look at the periodic table and I see it's beryllium who's positive 2 and oxygen who's negative 2, I just shove their symbols together, BeO, done. Okay. All right, so let's look at this. All right, so the first one says lithium nitride. All right, so step 1, write the symbol, Li, and the charge. That's where you're going to have to look at the periodic table. I don't expect you to memorize what groups they're in. Right? You get a periodic table. It's in group 1. Group 1 is always positive 1. Right? We always write charges to the upper right. And then the second one, we read it, nitride. This is why I taught you how to name them first. Is you have to recognize that nitride is what element? N. We find it on the periodic table. It's in group 15. 15, this is what you've got to get into your head, is always minus 3. Always.
Well, you skip 14, then you go
14,
2, 1.
yeah. Yep.
Okay, so then do 3.
1, 2, 3, skip. 3, 2, 1, skip. Yep.
So we're never gonna do 14.
No, we'll do them tomorrow. We're gonna add tomorrow to this. So you get the baseline down today, and then we'll add tomorrow. All right. So what we do is the 3, not the negative and the positive. You can ignore those. The 3 is gonna come down and tell me I need 3 lithiums. And so in chemical formulas, we always write them at the bottom for how many we need. So it'll be Li and then a little 3. And then this N, we only need 1 of. So you're going to put an N. We don't write ones. Okay? And this would be the chemical formula for lithium nitride, Li3N. And that's the goal, is to be able to read the words and turn it into how many of each. Side note, your symbols need to touch in your formula. That's how we show that they are bonded. Right? So like, don't put spaces between your symbols. All right, second example. All right, sodium is Na. Charge is in group 1, so positive 1. Fluoride is fluorine, that's F. Find it. 17 minus 1. Honestly, when they have the same charge, you can just shove the symbols together. It's like NaF. I mean, technically you're going to cross a 1 down for both, but you don't write ones. So NaF, NaF. All right, third one. Aluminum. Symbol, Al. Charge, look on the periodic table. And this is, you've got to get this down. Group 13 is positive 3. Read the second one, oxide. You have to recognize that that one is oxygen. Oxygen in group 16. 16 always makes a negative 2. All right, so the 2 from oxygen will tell you how many aluminums. So we need 2 aluminums. The 3 from aluminum tells me how many oxygens. Oh, 3. Yeah.
If it's in 14, you just add a Di before this.
Nope.
Because di also.
Nope. No prefixes in this. Carbon dioxide is covalent, not ionic.
But like, why is it covalent?
Because it's covalent. They share. That's going to be the whole next unit. We're doing just ionic right now. That's when life gets fun. All right, last example. All right, so last one, barium is Ba. You look on the periodic table, it's group 2. Group 2 is positive 2. Sulfide is sulfur, that's S. Look on the periodic table, it's in 16, it's 2 minus. So honestly, like I told you, when I see them having the same charges, I just shove the symbols together and write it as BAS. Okay. If you follow the steps, right, which I mean obviously is fine if you want to do it, you would take the 2 down to here, so you would say BA2. You would take the 2 down and you would say S2, and then you gotta think like you're in math class. You can simplify a 2 to 2. a 2-to-2 ratio is the same as a 1-to-1. Sorry you guys don't get much practice. I'm fired. You can do just the first column on the first page of the CYU.
What?